everybody, Dave here. These are the classic Pioneer HPM-100s. This pair came from a customer who purchased them online, actually. He thought he was getting two good speakers, but when he hooked them up and gave a listen, he was not particularly happy with them. And it's not surprising. So he contacted me and said, can I help figure out what's going on and go through them a little bit. We'll take a tour of them, show you what some of the cosmetic issues are. Then we'll take a look at the functional problems. We have a couple of areas of damage, which you might be able to spot one of them if you have a keen eye. And then we started doing some troubleshooting on them and identified some additional problems. So let's begin that tour and show you what we've uncovered so far. Right now we're waiting on some, the owner purchased some spare parts, and we're going to talk about kind of getting the speakers up to the next level. Let's have a deeper look. All right, let's zoom in here on item number one. We have the screen, perforated metal screen over the super tweeter is missing. So I'll pan over here to the other one. There you can see the perforated metal screen. And on this one, no perforated metal screen. Someone's also penciled in 1 5/8 by 2 5/8. And yes, I do have the extra screws. I have put these partially back together. We'll pan down here. We'll take a look at the next issue. Here you can see the dust cap has a hole on the edge. Someone's tried to do a repair. You see some glue residue there. I don't know if it's white glue or what kind of glue it is. It's something that dried white, but probably not a very good job on that. The cases, the grills are in decent shape. Just a little contamination there, a couple little pulls on them. I have to check and see if these are supposed to have badges or not. There are no badges on the grills. Here you can see a little bit of damage on the wood. There's a little dent and a hole there. There's some scratch marks. This kind of thing, this kind of cosmetic thing can be addressed fairly quickly and easily without a lot of effort. This is one of the back labels. It had been fallen off and somebody taped it on and it fell off again, but nice to have that. And let's go around to the back side and I'll show you where the real fun is. On the back side here, see, this is where the label was that has since fallen off. The other one is still stapled on. I've removed the binding post cups already, and they have the crossover directly mounted to the back of that cup. But here you can see that this one had already had some work done to it. There's some sort of cobbled together binding post on the positive lead. This is the original right here. That's what it should look like. And that's what we have here. And the customer said when he hooked them up, he thought that this one sounded fine, and he got no output out of this one. So that was his reported symptom, no output. So I decided, well, all right, it's time to start taking some measurements. And as I discuss those points, we'll pop up some graphs here on screen, and you'll be able to see that. I'm not going to share give you all the data, but we took some resistance measurements, got out the meter, took sound pressure level measurements and a sine sweep. And what we found was, well, sorry, let me back up. First thing I did was when I hooked up to the binding posts on the outside here, I also received no output here and didn't sound perfect on this side. Didn't sound like what I expected to hear on this one. So that meant I had to dig a little further, took some measurements, had open circuit here, and I don't remember what the data is, but a proper resistance measurement here. And so that meant let's dig in. So open them up, and let me show you the next things we found. Okay, this is the unit that had no output, and we see some sort of alternative binding post nut and screw on the back side here. This is the negative, and it just has a single screw with a fast on terminal that you can connect into. And on this one, we have some other thing. And everything else looked original here, which was kind of interesting. So obviously it had not been recapped or no other modifications made. We come over to the other one, take a look at that one. Here you see two proper fast-ons. So the first thing I did was I connected up not to the binding post on the outside, but to the two fast-ons on the circuit board, and lo and behold, this speaker came to life and sounded fantastic. And so we're making progress already. So we know we have an issue with this cob job on the binding post on the inside. That meant we needed to turn our attention to this unit to find out why the sound didn't seem right. So we started taking a lot more measurements. Measured the resistance of every individual driver, ran a signal generator to every driver, and I did that on both units. So we're taking resistance measurements, we're taking sine sweeps through each individual driver. I can't hear at the super tweeter level. The crossover frequency is listed at 12,000 and above for the super tweeter, and my hearing is gone at around 13 to 13.5. So we had to get out the tone generator for that. We actually disconnected the tweeter, so all we had was the super tweeter running, and found out that the super tweeter is actually working on both units. So even though the screen is missing on that other one, it doesn't seem to have affected the output. But the super tweeter, the woofer, and the mid are all working on this unit, and the same is true on this other unit. So the drivers are all working. It's just that the system output isn't quite right on this one. So I'm going to put up the full spectrum sweeps I did, and you'll see that this unit falls off. Can't remember where it is. I don't have the data in front of me right now. I'll put a number up where you can see it starts dropping off. Whereas on this unit over here, we do have a full output all the way up to the highest end, up to the 20,000 level. So here are the first plots that I ran of the the two speakers. This is just a standard sound pressure level. The details are not important. What is important is to look at the difference between the two graphs. So this is the speaker that sounded fine. Of course, that's when measured with the at the fast-ons inside the crossover, not on the binding post. So this speaker sounded fine to my ear. I measured it. It's got some ups and downs in here. And notice after 2 kilohertz, it maintains the same level all the way out to 16, 17, and then drops off. Compare that to what you could hear with your ear, and now we've measured it with data. Similar, a little bit rough, up and down, up to the 2 kilohertz point right here, but above 2 kilohertz, this speaker drops off fairly linearly out to the 20 kilohertz. It never maintains the same level as it was previously below 2 kilohertz. So that was the first thing that matched, that first piece of data that I collected that matched the ear that said this speaker doesn't sound right. And of course it was missing the mids and the highs. So there you have it. And not nearly the correct output here. So I started looking at that, and my first thought was, well, there's a transformer here, and I didn't understand how the circuit works. So I had to go get the circuit diagrams. I thought perhaps somebody may have messed around in here, because I found online quite a few references to the wiring, because obviously some of this is going to the L pads on the front here. You can see we've got a mid. Oh, you can't see, sorry. We've got the pots here, which are meant to adjust mid and high end, and those are wired in to the crossover directly. So I thought, well, maybe there's something going on with that. So we started taking some measurements across the range of that. Also found online quite a bit of history with these needing to clean the pots. It's not easy to get at those pots and get them clean, but that's something that is now on the work list to get done. But as I started digging into this, I thought, well, we're going to get deeper here, and I'm doing a no-charge diagnostic for this customer. So I'm trying to, without desoldering components and checking caps, I'm trying to determine, where can we go with this? I found out that from the factory, there is reverse polarity on a couple of the drivers. So you do have to check that. And they put them out of phase intentionally from the factory, is my current understanding. So that influences, which is ground and which is positive coming into and out of the crossover and the L pads, which can get a little confusing in there. So I traced that down. Everything looked correct. Everything looks like it did according to the factory wiring diagram that I'm using as a reference, which came from Audio Karma. All right, let's do another sidebar here. I went on Audio Karma and looked for additional information about the HPM-100s. Here's the factory wiring diagram, and there's some important notes in here regarding this lower image, which is provided by folks online, which shows that the service manual wiring diagram is incorrect in terms of which is positive and which is negative on the various drivers here. So this is what I used as the reference for what the wiring should be. So if you have a pair of HPM-100s and you want to make sure you've got the right circuit diagram for the crossover, this is it. I started looking at these caps and trying to see if I could make some more determination on checking individual components. And as I started digging into that, I realized that there's another issue here. And I don't know if you're going to be able to fully see this. We'll try to get in here and get the light at just the right angle. You may or you may not be able to see it, but there's a hole in the board right here, and there's a crack in the base PCB that goes all the way across the back side here, all the way through here over to where this capacitor is. The board is broken. So, and there are traces in that board. It's not just point-to-point wiring. There are actually some embedded traces on there. So obviously somebody's been in here, mucked around. I I don't know how that happened, but it's probably contributing to the problems that we're having. And you've got original capacitors here. The rest of it's inductors and resistor, and probably not much. And I measured the resistors. The resistors look good. The transformer seems to be working because the super tweeter is working correctly. It's, I believe, an 8-to-1 on the transformer, and that's part of the measurements I took. Inductors, there's really not much that can go wrong with those, but if there is a problem in the circuit and on the board, that could contribute to the fall off that we've seen. So that's where we're at right now. I identified a variety of things that I thought the customer could consider, and of course could, and because this is such a popular, well-regarded speaker, there are a variety of alternatives, right? He could just sell them as is and save his money for something else. He could do some of the cosmetic upgrades that we looked at earlier and clean them up a little bit, maybe make a little profit that way. He could do a full upgrade. There are upgrade services that are available online to change out the crossovers, give you upgraded components on all the crossovers. You send these in and they send you an upgraded crossover back. That's an option. You could go the whole GR Research type of upgrade. He has it's a $750 upgrade for these, and if you go online and look at YouTube and watch the video, the claims that he has for the HPM-100s are quite good and quite dramatic and something to consider, but pricey. And what we've decided, or what this customer's decided to do, is purchase a new, sorry, I won't say new, purchased a used crossover that appears to be from a parted out speaker. And so he's got one new crossover coming with the binding cup and with the L pads. So with the adjustment pots. So with that, we should be able to change this board out and all the components on the board. We should be able to then use this binding post from this damaged crossover and fix the other one. So that should get us much closer to where we want to be. And we'll probably have to go through a pot cleaning if we need to do and use some of the replacement pots that are part of the crossover and adjustment pot purchase that he's made from eBay. Then that could go could go into one of the units if we find there's an issue, but I think I'm going to start with just a simple cleaning. One thing I forgot to mention when I was talking about diagnostics, here in my southern workshop, I have a fairly basic, simple scope to do some signal probing with. And with this probe, we were able to identify pretty clearly a significant difference in the signals running through the two crossovers.
With the small little pocket scope we have here, this shows the differences between the two systems that I was able to find and measure easily, further contributing to my confidence that this bottom crossover was not working correctly. So I was probing various points on the two different crossovers, and here is the good crossover. Sorry, it's off the screen, but we're at 2.5 volts peak to peak and fairly stable signal. On the bottom image here is from the crossover that has the crack in it. And, you know, I'm not saying the crack is the reason for this oscillation that we see in the wave, but it's not helping, right? And there's perhaps a problem with some of the capacitors, possibly. I'm not an electrical engineer, even though I might sound like one on YouTube sometimes. I cannot tell you what the cause is of this oscillation on an audio sine wave. But I know it's not right when the other one sounds fine and this one doesn't sound fine, right? You can learn a lot by finding differences, even though you may not fully understand the root cause. And so using this information, you know, this was helped me to tell my customer that there's a problem and we need to work on that crossover more. Those of you that are electrical engineers can probably point out exactly which component it is in the crossover circuit that probably causes this kind of oscillation on top of a standard sine wave.
So that was the confirming point for me to tell the customer, you know, there's definitely a difference. This difference is likely. This combined with the broken circuit board, which one's the chicken, which one's the egg, is always difficult to determine, but not a good situation for this crossover. So that was what led us to the fairly cost-effective decision to just go after another crossover and see if we can bring the high end back to this speaker and make them pleasurable to listen to again.
3 weeks later.
We now have the replacement binding cup with the crossover wired into the attenuators that my customer purchased from eBay. It looks like it's in really nice condition compared to the one I have. I think all the sealant on here looks much nicer. It's definitely cleaner. Everything appears to be complete. Everything appears to be wired identically to the one that was in the speaker. All the wire colors match. I know that it's difficult to pull these out of the box, and you can see the person damaged this corner, glued in this plate, the little emblem plate. They damaged that as well down here trying to get it out. So my first plan is not to reuse this. So we'll simply disconnect the wires here on the fast-ons, and we'll plug our existing wires into here. We'll come back when that's completed, and if I find something between now and then, I'll show that to you as well. I think we'll make a short clip here regarding what went wrong, and it's not hard to envision what went wrong when somebody worked on this crossover. So once you remove all the screws, the binding post or the binding cup doesn't come out easily. It's not obvious how to get it out, and it seems to hang up here on the lower edge. The upper edge tips, but you can't tip the lower edge. And by the way, the reason you can't tip it is that the circuit board extends down inside this back panel. So I believe how the other one was broken was somebody got under here on this bottom edge and just tried to wedge it out. They tried to force it, pry it, wedge it, and that's what cracked the board, as we showed you in the photo. What you need to do is you need to start at the top and tip it out, and you'll see this cutout right here. That cutout, that semicircular arc, is meant to be the arc for the inductor housing to come out through that arc. So you kind of have to wiggle it back and forth until you can get it out. And you'll find just the right spot, and there it is. You can get it exposed, and this might be where the person broke it. They got it this far, and it's still hanging up down on the bottom, and they just forced it too far. But you just kind of have to work it, and then you can get it out. So there you can see how the circuit board and the binding cup flange kind of are trapped, surround that back panel. And that's what you have to be careful of, because otherwise you're going to break it right where the screw mounts are. And that's exactly what happened. So that's the how-to and the how not to, and hopefully that helps somebody. Just to wrap up, where we started on the speaker that we ended up replacing the crossover, there's that plot showing the drop-off above 2 kilohertz. And here is the new crossover, the system measured with the new crossover in that unit. 8426 is just the serial number of that unit. And there you see, still a little lumpy, but once we're at 2 kilohertz, we actually get a bit of a rise, which coincidentally, if you look at the diagram on the label, is what the factory shows. It shows actually a rise in the upper end. So, that probably indicates that the crossover in the other speaker, has degraded some. And if you want to get back to this has a bit of a smile shape to it. A lot of people like this kind of shape, a little high on the low end, a little high on the high end, and the middle here in that 500, 250 to 2,000 range is depressed a little, and everyone has a specific taste in what they like their music to sound like. So here's the summary of that before and after, and of course this now sounds much better as well, and the customer was really happy with this final result. Let's take a quick look at the cracked circuit board. Here you can see the crack starts here, heads over to this where the binding post attachment screw is, comes across here, goes right through this trace, over here to this inductor. Looks like the crack goes up through this trace as well. Board's cracked over here, comes across here, doesn't go through that trace, maybe goes around that solder point right there, but goes right through that trace as well and right out the other side. So no bueno. There it is, little Cha-Cha Fontanez. Thought you'd want to hear that. Speakers are ready for pickup back to the customer. He's going to do the other work on them and enjoy them for a long time.